Hello everyone and welcome. This is Science Visualized and today we're looking at chromatography, which is used in organic chemistry. Chromatography is a very important separation method. Chromatography consists of a stationary phase and a mobile phase. So I will draw an example here of what we call column chromatography, and then it's packed with, say, silica gel or alumina. And that becomes the stationary phase. And then what happens is that you end up applying the mixture to be separated above the column. So that's the organic mixture. And then next, you introduce the solvent, or it could be some type of a gas, depending on which type of chromatography you're talking about, and that will be the mobile phase. So what's going to happen is that the mobile phase will dissolve the organic compound and then try to push it through the column. But as it does that, the organic compound adheres to the stationary phase, the silica gel or either the alumina. So you have the alumina here, for example, and then you have the solvent with the mixture attaching loosely to the silica gel. So all that happens while the solvent is applying a pressure, pushing the organic chemical out of the column. So as a result, you end up separating the mixture because different types of mixtures will adhere to the silica gel with different amounts of strength or energy. And as a result, you end up collecting what we call fractions. And then we'll say that number 1, number 2, number 3. And most likely, you end up with different products in number 1. So say product A, product B, number 2, and product C in number 3. Because each of them will have different strengths that it adheres to the stationary phase. So the end result is that you end up separating a mixture into its components based on the degree at which it adheres to the stationary phase. In chromatography, you can change the pressure, you can change the temperature depending on the type of the chromatography, you can change the type of solvent, and that means you can use non-polar or highly polar or polar, depending on what mixture you want to separate. And the key is that you want to balance the polarity of the solvent in such a way that you end up with good separation of the mixtures. Now, just before we end, there are various types of chromatography. The first one is column chromatography, and that's where you use a column and then you put a stationary phase inside, and then you'll apply the solvent, which will push the mixture through the column. Number 2 is thin layer chromatography, also called TLC, where you have a glass plate that's painted or smeared with alumina or silica gel, and then you put a line here and you introduce the mixture that you want to separate. Then after that, you place that into a beaker that has a solvent of a particular polarity. So you have the TLC plate there, and then the solvent will move up the plate, and the end result is that now you have a TLC plate, but now the mixture has moved. You've ended up separating them, and that will show you how many components that mixture contained. Number 3, high pressure or high performance liquid chromatography. It's almost similar to a column chromatography, but now you use high pressure to push the solvent through. Number 3, gas chromatography. Also has a column, but now you use gas, most of the times helium or hydrogen or nitrogen is used. There are many other types of chromatography, but this just gives an idea of chromatography as used in organic chemistry. Thank you very much for your time. Please consider supporting the channel by liking the video and also by subscribing.